Welcome, everybody. Thank you so much for taking time out of your Fridays to be with her. We are very fortunate today to have with us Professor Kobi Gal. Uh, Professor Gal is an associate professor at the Department of Software and Information Systems Engineering at Ben Gurion University of the Niger, and is also a reader at the School of Informatics at the University of Edinburgh. In his research, Professor Gal combines artificial intelligence algorithms with educational technology towards supporting teachers in their learning students in their learning, and also teachers in their understanding about how students learn. He has published widely in highly refereed venues and topics ranging from AI to the learning and the cognitive sciences. Gal is the recipient of the Wolfs Foundation's 2013 Krill Prize for Young Israeli International Fellowship and a three-time recipient of Harvard University's Outstanding Teacher Award. In 2020, he was appointed as a senior member of the Association for the Advancement of AI. He has received numerous Best Paper awards. He has received a Best Paper award at the ACM Conference in User Modeling Adaptation and Personalization in 2019, an ACM EC Best Paper Award in 2016, and Educational Data Mining Best Paper Award in 2014. He's also an associate editor of the IEEE Transactions on Learning Technologies and a member of the editorial board for the Journal of AI, Artificial Intelligence Research, JAIR. Thank you so much, Professor Gal, for coming here and for sharing your research with us. And we really look forward to your talk. With that,
Sure,
feel free to get
wonderful.
started.
Great. Please call me Kobe and interrupt me whenever you like. So I'm from Israel and we love interruptions. And the second thing I'll say is that it's an honor to be hosted by State College. I was there 2 years ago. I did a bicycle ride in Pennsylvania from Pittsburgh to State College to raise money for battling MS, multiple sclerosis. And I was actually amazed by how big State College was and how big the university was. So I wish I could come over there. But for now, we will settle for Zoom. Horrible, horrible Zoom. And so I will share my screen. Okay, can you guys see my screen?
Yeah, we can see it.
Great. So because I'm sharing my desktop, I don't think I can. Yeah, if anyone wants to ask a question, just interrupt me by voice. It's
Okay.
okay.
Yep. Yep. Yep.
Great. And I should also say that this talk is aimed both at practitioners of computer science or social science, so you needn't be an expert in either. And I think it's just wonderful that you guys are having the seminar series because for me, using AI as a tool to help socially relevant applications make an impact in the real world is something that is very dear to my heart. And maybe I should begin by just mentioning the fact that it's 75 years since the first digital computer that you can see here in the picture, ENIAC, which represented the kind of predominant paradigm of one person, one machine, one place, right? This old view of computation that was pretty common when I was growing up still. And there's a reason why you see a woman here, right? Because the people who were working ENIAC were women. Being a computer programmer wasn't considered to be a very good position. And so they hired women for it. But today, of course, we have come a long way from that. And we have the predominant use of computers today is within many people, many machines. And this is creating a kind of a society. So that's why I'm so excited to be doing AI today, because it's a growing opportunity for computers to be working together with people as kind of collaborators, right? Whether providers of intelligent interfaces or even as autonomous teammates that make decision with us and can help us by giving us advice or being assistants. And I really care about how computers can help us become better collaborators in socially relevant settings, which is why I'm so happy you guys invited me. So let me just give you a few examples of stuff that I really care about. So Stack Overflow, that's a large scale online society that cares about helping, right? It's disseminating knowledge about programming, and all of my students use Stack Overflow, and I still use Stack Overflow, and I can gain insight from a high school student in India. I think that's just unbelievable. Or citizen science. I don't know if you guys know about citizen science, but it's an application I'm extremely excited about. The idea is that people all over the world can roll up their sleeves and help scientists discover knowledge about the world. What you're seeing here is Galaxy Zoo, which has over 1 million users. And the idea is that you're helping people classify celestial bodies, as you can see here in the picture, that come from Hubble Space Telescope and other electronic microscopes that are distributed. And you're helping astronomers understand the structure of the galaxy just by helping classifying these images, which turns out are quite difficult for computer vision algorithms. So having the human in the loop here as help is really beneficial. And my student Nick is doing a PhD on explainability about how to get students to work well when they're in these immersive simulations that you're seeing here. This is in the New York Hall of Science. And what you're seeing here is a simulation of a connected world. And the idea is to teach students about ecology and causal thinking. So there are, you can see there in the background, there's a waterfall, and the students can manipulate these logs. I'm not talking about digital logs, but actual logs, right? They're made out of foam. You can see that there. And they can control the flow of water into a system where there are biomes. You can get plants to grow and animals, and you have to learn about how to manage your resources in an imperfect world that's ruled with stochastic laws. So it's a wonderful educational society where students learn together. And here's another application of exploratory learning environments. What you're seeing here is simply students working together collaboratively to solve a geometry problem. And it may sound very simple to you, but it's actually amazing what students can do when they work together. So this is an experiment I'm running all over Israel. What you're seeing here is, this is actually in an Arab village in the north. The students are talking to each other about solving a problem that I'll show an example of in this talk. And the idea is to help teachers understand when the collaborative group is encountering critical moments or problems that require interventions. Okay, so if all of these societies work so great with the help of computers, then why am I giving this talk? Well, the fact is that they work well, but there are huge problems that kind of deter us to scale up the benefit of using computers today. And the issues are that these teams are completely voluntary based, and then there's a big disengagement problem here lurking. Now, don't take my word for it, just look at the data. So what you're looking at here, for example, is traffic on the Galaxy Zoo website. On the x-axis, you can see how many tasks users are doing. And on the y-axis, you can see the number of users. So it's a kind of a histogram. And as you can see, it follows a right skewed distribution. So most people do very few tasks, actually fewer than 10, before they give up and leave the site. And an amazing statistic is that once people leave Galaxy Zoo, most of them don't come back, like 70% will never come back. So think about it, you only have a very slim chance of catching people to get them to work and benefits science, in this website at least. What you're seeing here is a graph created by my student Stavianovsky, who studied badges in Stack Overflow. So this is how they incentivize people in Stack Overflow. You're giving badges, like if you answer a question that was dormant for a long time, you're going to get the I forgot the English adjective for it. Someone like who resurrects something. So you get a badge for resurrecting a message. And these badges are wonderful. They really get people to work. As you can see here on the left-hand side, the closer I get to earning a badge for doing work in Stack Overflow, the more I'm going to work. The y-axis is the number of activities you do per day. But as you can see, once I get the badge, the effect dies off very quickly and people go back to their default level of distribution of contribution. So the badges don't work very well. They work for very short kind of spikes. This is called the steering phenomena. And because of this issue, there's a lot of work in AI on trying to get people to be incentivized in these kinds of group. So, let's do like a very quick summary. So what I love about this kind of open group work society is that it's a fundamentally different than the type of group work we're used to in AI, because it's so diverse. Like, the people who participate in it have diverse skills. Some people are experts in galaxies, some people are experts in cell biology, and they have diverse motivations. Like, I sometimes can log on to a course on the internet because I want to steal some of the material and teach my students, or because I forgot how to do logistic regression. While other people, like a housewife in India, she's logging on to get a degree. So people have really diverse motivation, and that affects the way they participate. And the participation is completely voluntary. You don't have the ability to pay people for participating, and still you want to generate and disseminate data because these are socially relevant applications. So really the crux of the matter is how to keep participants motivated. And because I come from the world of AI, there's a lot of work on, as I said before, on incentive design. I'm just giving a few examples here about building environments that kind of get people to do the right thing, trying to design and agents that can kind of nudge people in the right way, using probability and utility theory, as well as trying to collaborate with their human users. But today I want to focus on a very particular kind of agent, one that can intervene with this society of humans and trying to push them towards collaborative and beneficial behavior. So, maybe this is kind of scary to have agents that intervene in the world, but in effect, we're all susceptible to agents that intervene, right? When we log on to YouTube or CNN, we're getting recommendations about what songs to watch and what items to read, and that is an intervention. It's an agent trying to affect the way we behavior, the way we behave, and that has consequences. And I want to talk about various applications in my lab about dealing with these consequences in three domains. So the outline of the talk is going to focus on three domains that are socially relevant, where we've designed intervening agents using AI technology, and I'd like to tell you about the results. And we'll talk with citizen science, and I'm going to stay within the realm of this Galaxy Zoo. And I just told you that we're trying to intervene. So in the Galaxy Zoo domain, all I want to do is to push that histogram a little bit to the right. So I want to get people to remain for a little bit longer on the site and contribute. And when you think about it, there are multiple dimensions where we can intervene. So we can intervene by providing feedback, and then the feedback that we provide, we can decide when to give the feedback. Like, at what point in time should we tell someone, please stay longer, or maybe push him a little, him or her? What kind of duration should this feedback have? And what form should it take? Is it a sound bite? Is it an email? There's a lot of people sending out emails to me every day, trying to get me to come back to various applications that I've downloaded, and I'm very good at ignoring them, right? And so there's a kind of a wide sphere that we have to consider with multiple dimensions. So that's the first thing I will say. And then the second thing I will say is that, coming from AI, I'm going to treat this as a planning problem, whereas this agent you see on the bottom, it's getting observations from the environment. So I'm collapsing the entire citizen science project with the people to this obtuse environment that's giving me observations. And then the agent can decide when and where to intervene and provide a message to a person. So it's going to be a personalized message that we're going to generate for people. And then based on this intervention, we're going to observe a reward, which is simply how much longer this person is staying in the website and performing useful contributions. And this creates a loop, this kind of well-formed loop. Anyone here who's taking an Introduction to AI course will have seen this loop. So we're going to kind of take this interventionist planning idea, and I won't go over the equations because they're not important. Let me show you the kinds of feedback messages that we generated. So here we were inspired by the social science literature in citizen science that it turns out has done studies about what motivates people for contributing to science. And we found out that one aspect is just people want to feel good about themselves. So, let's kind of pat their shoulder. Don't stop just yet. You've been extremely helpful so far. Your votes are really helping us to understand deep mysteries about the galaxies. That's one type of message we can generate. Another motivation that lets people, that kind of controls people in citizen science is that they want to help science. So they don't care less about feeling good. They really want to help the community, the scientific community. So for those kinds of people, maybe you want to say, remind them that there are all of these thousands of people taking part in the project, and they have a forum website. They can discuss the images and do lots of fun stuff together. And lastly, we ourselves, through interviews that we conducted in an EU project with citizen scientists, we found that some people quit the site because they're afraid of making mistakes, which is kind of funny, right? Because it's fine to make mistakes. The same picture goes out to hundreds and hundreds of other volunteers. So for those kinds of people, we want to say something about anxiety relief. We use statistical techniques to get the most from every answer, so don't worry about being wrong. So I just showed you 3 types of messages, and then here's the way I'm going to deliver the message. So we're working together with the Galaxy Zoo administrators, and they allow us to intervene directly on the site in a very violent way. I mean, it literally looked like that. And the other thing I will emphasize is that you can see here on the bottom, it allows one to opt out from smart messages. And I'll say a few words about that later. Because what you really have to care about when you're using AI for intervening in the socially relevant applications is the fact that there are different stakeholders in the system. And you want to be very careful about not pissing anyone off, and being careful about respecting people's privacy and people's honor. And for that, we were instructed by the Galaxy Zoo admins not to interrupt in this way at most above once per session. So a session is just a contiguous amount of time that someone is working before logging off the site. So I'm only allowed once to interrupt. So you can think about it as a kind of a stopping problem. Every time I'm seeing this, I'm like a friendly parrot on the shoulder of the volunteer. Every time I'm seeing the volunteer click on the galaxy, I can decide whether or not to interrupt that person. And I need to make a trade-off, right? Because interrupting relatively early might be great, but then I'll waste my coin. I won't be able to interrupt later. But waiting a long time before interrupting, I might lose that person because he or she might log out of the system. So it's an interesting stopping problem. And the other thing they told us, don't you dare touch our super users. They have a lot of users in Asia, by the way, that do hundreds and hundreds of classifications every day. So they really didn't want us to touch them. And also they said you have to allow this opt-out option, because if you're pissing someone off, you don't want that person to stay. And so what my student Avi Segal did is he created this, we call it a trajectory approach, a TCI approach, where essentially you're choosing our presentation. I spoke about an environment, so we're going to choose a representation to define this environment, and we're going to use reinforcement learning to learn an intervention policy. And here, the idea behind the intervention policy is, given the state of the world, which we'll talk about in a minute, should you intervene and with what message? And we're going to construct a policy that we will need to evaluate before we deploy it in the real world, because that's another very important thing about doing studies in socially relevant real-world problems. You really want to make sure that your policy works, because if it doesn't, you're going to screw around with a lot of people and getting them very, very upset. So the representation we chose was kind of inspired by a list of papers on citizen science that appeared in the AI community that provided probabilistic models, for example, of predicting when someone is about to disengage. And so we looked at a set of continuous features, and we saw these most important features included how many sessions someone has done so far. I'm reminding you that most people only do one session, and how many clicks or tasks they performed in a session, the time. This turned out to be very interesting. The dwell time between clicks, that was a good clue for if someone is getting discouraged. You would think that longer dwell time means that people are becoming bored, but maybe it's also just meaning that they're thinking hard. So it's a kind of an interesting stochastic relationship between the dwell time and someone's motivation or engagement in the task. And then we realized that we need to do a randomized intervention trial. And here again, as an AI scientist, I needed to learn a lot about how to perform these kinds of intervention trials in the wild, So you want to make sure that you have users who participate in different cohorts and the ability to collect training, validation, and test set. And indeed, uh, we negotiated this with the citizen science admins. They allowed us for a matter of a few weeks to randomly generate interventions on their site. That you saw those three messages, we flipped a coin and decided to which intervention to produce and for whom. And then we collected data about what happened. And then we, as you saw, we were able to intervene for about 5,000 users. And this was very helpful to us because it provided us with a little bit of data to do the reinforcement learning on. Not a lot, a little, but you have to be very, very careful here because essentially you're just, you might be, again, you might be pissing off people by interrupting them when it's not necessary, right? Think of some people here I think are still old enough to remember Clippy. Are you trying to write a letter? This is what we were trying to avoid. And so once you have a training set like that, you can define just a straightforward reinforcement learning problem. I'm just showing you a bit of the model, but it's actually pretty simple. So at each state, and I showed you the representation earlier, you can decide whether to interrupt or not. And if you interrupt, you get a reward, and that's the end of the day. Or if you don't interrupt, you move on to the next state with some given probability that we were able to infer from the training set. So given that you've done reinforcement learning, you can infer an intervention policy. Now, this policy by definition is deterministic. It will tell you for exactly each state whether or not you should intervene and how. But we also have to evaluate it. And this was very interesting. So we generated a target policy, which again is deterministic, but the training set is a behavioral policy, right? It's not deterministic because in the real world, people are stochastic. They behave in many different ways. And so you can't just take this target policy and assume that it's going to work in the real world because the behavior policy might be very different from it. And it turns out that there's, in the reinforcement literature, this is actually a well-identified problem. It's called the off-policy policy evaluation problem. And we looked at some estimating techniques that allowed us to take the target policy and see how good it is by kind of computing an unbiased estimate of this target policy with respect to the policy that generated the behavior policy. And I won't go into the math, but this is a well-known technique from the reinforcement learning that is going to allow us to fix the policy. So here's an example of the target policy that we got. For example, when the user is productive and works slowly, and I know that because I can look at the lag time in that state and how many tasks the user has done, and whether or not I have this straightforward Bayesian prediction that is telling me that the user is not likely to leave. We had a threshold. If the user is likely to leave the site with above 55 or 60%, then that constitutes a 1. And so if the user's probability is less than that, then the policy told us to tell the user that thousands of people are taking part in the project. But when we applied the off-policy correction step that I told you about earlier, we actually got this policy that was this message that is different, that actually tells the person that it's okay to make mistakes. And when you think about it, I actually think this is a better message to be generating in this state, right? Because indeed the user is productive. I mean, that user is not leaving. He or she is just working very slowly. So maybe they're actually quite hesitant. It's okay to tell them, hey, you can make mistakes. Don't worry about that. So based on the corrected policy, we can deploy this in the Galaxy Zoo setting. And what you're looking at here is this kind of air traffic controller. This is the Zooniverse server we created at Ben Gurion University. And this server ran the study. Essentially, all of once someone logged on to Galaxy Zoo, they generated a transaction in our server. And then we randomly disseminated people into a random intervention cohort, which, as I mentioned before, just gets a random message, an optimal intervention, which uses this reinforcement learning, and a myopic intervention that only fires when you think the guy is about to leave. So that's a kind of a greedy approach. You're not looking into the future. You're just seeing whether the guy is about to leave, and if so, you're just firing any kind of the messages.
Kobi, I have
And
a clarifying question.
yes, of course.
So the interventions that you're talking about, do they only is it only is does the intervention only is our action space, does that only contain whether at each point of time are we going to fire a message or not, or does the action space also include what particular message are we firing?
Yeah. What particular message?
Okay.
You're right. And so what you're looking at here is the distribution. Thank you for the question. The distribution of the messages. So most messages that we fired were helpful, but we also fired some community and anxiety message. And I want to show you before we continue to the actual result. This is a study, as you can see here, we ran 4 years ago, where we only used a myopic approach. So we're just firing either no intervention or we're firing, you're doing a great job. That's the helpful message. You're doing a great job at random, or you're part of a great community at random. But you can see here that when we are firing, you're doing a great job, when the predictor thinks that the guy's about to leave, we're doing much better. We're actually doing, if you're just doing something randomly, you're pissing them off, right? You're doing even less than you would be by not intervening. But it's not only, it's important to understand when someone leaves, but also what to say when someone leaves. So even when we predict that the guy's about to leave, but we generate some other type of message, we're not going to be doing as well as the helpful message. So we knew that the helpful message was good, but the amazing thing is that it's not a silver bullet. So the optimized corrected policy, if we look at the tasks per session that people do after they are being interrupted, was indeed better than this myopic policy I showed you earlier in our test set. So it's not that you should only generate the helpful message. Sometimes you need to tell someone that it's okay to make mistakes. Sometimes you need to tell someone that they're part of a community. And that's the beauty about the personalized feedback, is that you're trying to hone in on what motivates the different users. And you're doing that by using this machine learning and planning approach. And so the last thing I just want to show you is that there's no data like more data, as the saying goes. And this is kind of sad news, right? If we only had additional session histories of people, we could actually be doing much better at predicting whether or not they're about to leave. But as I said earlier, most people just log on for a single session. And so it's very hard to understand when someone is about to leave the site. And as you can tell, this research did not attempt to solve that problem. And the only problem it attempted to solve was, given that you are on the site, how can we get you to stay a little bit longer? Okay, so
One more question, Kobi. So in this, I mean, when you talk about prediction, I just want to make sure that I understand correctly. You're not explicitly trying to predict what kind of a message do they want, right? That is being done implicitly by the reinforcement learning algorithm.
Exactly right.
Yeah,
that's
okay.
exactly right. When we do prediction, and I didn't go into it at all in the talk, and we're thinking about whether or not they will leave. So when they log out, when they disengage, when they drop out. There's a lot of work when people drop out of these systems. So MOOCs, for example, has an established literature on when people drop out of the course, because they want to make sure that people stay as much as possible during the course for the course. Okay, so sure. Thank you. And anyone else has any questions before I move on to the next?
Yeah, Kobi, can I ask a question? So,
Sure.
so what you're doing, really, you're like targeting the middle of the people. Like if you think about like people contribution to these type of websites, like the citizen science is kind of like a Gaussian curve or something. So you're really targeting the people in the middle. Is there any way to kind of try to target people who are on the corners of this kind of distribution, like people who do not engage as much, they have very little engagement, or people who are engaging a lot, but you want to kind of somehow incentivize them to even kind of contribute more?
Right. So I think that's a great question. And so they didn't let me touch the people who contribute a lot. I just right? If you remember, I told you that the super users uh, weren't receiving any intervention. They didn't want to mess with them in this particular. And you're right. The people who log on for a single click might not receive any intervention because we're risk averse. And I don't have a good answer for you. We haven't. So for example, for those kinds of people who don't even log on, you need to approach them differently. You need to cast a different spare, like sending them an email, or maybe recommending the right project for them. So I'm not talking about it in this work, but in AAAI 21, I have work on intelligent recommendations in citizen science. And that is, you have this dashboard and we're trying to understand what kind of project should we recommend to you based on what projects you've tried in the past. And then if all you did was enter the project page and you didn't even make a single contribution, it's still useful information for me because I know that you entered this page. Most likely you were interested in the project, even if you didn't contribute directly. Thanks for the question.
Yeah, thank you.
Okay, so let's talk a little bit about course forums. I teach Introduction to Probability in Israel to 200 students this year, starting next week, my God. And then I'm teaching a course at the University of Edinburgh for 300 students. And it's always a very difficult to get them to interact in the forums. We want them to interact together in the forums because, again, when the students interact and they respond to each other's questions, they think more critically, they assimilate the material, and they understand concepts better. Much better than I can describe the concepts because I've forgotten what it is to learn. Can we get students to be more collaborative during class? Of course, they have all of these Facebook and WhatsApp groups, but can we actually get them to interact directly on the course material in a way that evolves their learning? And there's a very nice tool for forums that was developed by David Karger at MIT called Nota Bene. And the idea behind Nota Bene is it's a collaborative annotated forum. What does that mean? Think of a Google Doc. So you get a reading material like a textbook or even a movie, and then you select what part of the reading you want to comment on, and then you include a comment on the right. And you can see here, you can scroll and see everyone's comments based on the context rather than a time-day hierarchy. And think about how much more useful that is. So for example, if I'm studying for an exam, I'm going to be able to see what everyone wrote on a particular topic because the comments are anchored to the text, to the reading material. And that turns out to have actual learning benefits for students when compared to traditional forums. And students are actually more likely to like to use forums that are context-based. And so Nota Bene is free software. There's also a Perusal and Hypotheses. All of these are context-based. Some of them are free, some of them are half free. And I really recommend anyone who wants to consider them to use in the course. They work very well where you have a course and reading material. Okay, but I'm not an educational guy. I'm about to, oh, sorry about that. I want to use AI for something. And so I'd like to tell you about our collaborators at the University of California at Davis. So they teach a biology course for all life science majors. It's called Biz2A. It has 800 students, and it's kind of a flipped classroom course, 26 lectures, including a midterm and a final. And the students are required to submit questions using NB for each lecture. So they're reading material at home, and then they're submitting questions before the lecture. They have to submit questions. It's part of the course requirements. In fact, they have to submit the questions by 11 p.m. The day before lecture. And of course, I mean, if you can imagine what happens is most of the comments come in at 10:58 and 10:59 p.m. And there's no way for the 6 or 7 instructors in the course to do anything before they actually come to class, which is a pity. Like all of the discussion that's going on in the forum isn't staying. And another nifty thing that I just want to tell you is that the students are also encouraged to use emoticons when they comment. So I just love these. And so we developed these emoticons for them. You can tell someone you're confused about something in the textbook, or you're curious, or you need some help. Even if you're frustrated, you can tell people. You can see not too many people were frustrated, but there were definitely people who were confused. You can see that that's a count from a single instance of the course. They do that just by specifying the hashtag, just like on Twitter. So, you know, as you can imagine, most students are just going to do the easiest thing, just do a question and ask something, and no one will reply to them. As you can see here, 52,000 of the comments just in one semester were like that. They had no responses, and very few threads got a lot of responses, which again isn't good, right? Because the good stuff happens here when the students talk to each other in the simulator. So how do we get them to do that? I mean, it happens. Sometimes it happens. So here's a big idea. How about to do a little seeding? So imagine that you're about to initialize a new instance of this course, and you've taught this course in the past, and you can see which kinds of threads were beneficial. You have these instructors that can review the course in hindsight. And how about to pick some of these interesting posts, just the first post, and seed them or initialize the new course with that particular message. And to do that, we sat down with the instructors and we came up with this idea of the seeding scores. So take a look at this table. What you're seeing here, for example, is the first post that the instructors gave a very high score to. A seeding score ranges from 0 to 3. So this guy is talking about energy and food, and the instructor thinks this is a very good post for seeding because it forces students to think about inputs and outputs of the biological system that they were studying. And in contrast, look at the last one. My past course focus on ecological biology, blah, blah, blah. This discussion is all about course logistics, so it gets a very low seeding score. Now, why am I showing you this? Because you can see that the length of the thread is actually not that indicative of how important a first post is, right? You would think that longer threads should mean that the first post is actually more beneficial to learning, because it just said we want to get people to interact more with each other. But it turns out that you need to consider not only the length of the thread, but also the quality of the thread. And I'd like you to keep that in mind for another slide or two.
Kobi, a quick question.
Sure.
So how do you assign the seeding score? Is it like qualitative based on teachers, or do you somehow learn that score?
So the teachers were willing to sit down, and we built a table with
all of them.
a decision tree, a manual decision tree, and then they sat down 3 or 4 of them and manually labeled like hundreds of posts for us. It was very time consuming.
Wow.
But you're getting at the crux, right? So what we did then, of course, is we built a computational classifier that was trained on about 5,000 manually classified seeds. And the purpose of the classifier was to automatically provide us with a seeding score for unseen seeds. So we wouldn't have to keep asking the teachers. And I won't talk about the lexical. I already said that it also, obviously, if the first post is a question, then that's going to generate some discussion. But I want to talk about the last item here, which is called cognitive engagement. That was one of the features that we considered. And cognitive engagement was developed by Chi and Wiley, who are both computer and cognitive scientists. And the idea there is to look at behavior in a classroom. I'm going to focus on foreign behavior as a pyramid. So if a message is off topic, then it's the bottom of the pyramid. But if the message includes, but if the message includes a question, then it's still not very profound, right? Because you're not doing any processing of information. You're just asking a question, but you're above the level of off topic. You're considered to be active. And constructive is when you're doing something that's a bit better, that has a bit kind of processing in it. But interactive is the best one, because then you're not only doing processing, you're also interacting with others. So look what I emphasized here in red. That's why it's at the top of the pyramid. It's the person that is reflecting on what the others said, and that it's talking about the interactions and about the material. So again, this is where the good stuff lies, and this is where we wanna go. And that's why the quality of the discussion was very, very important for us. And we did build a separate classifier based on data that we have of people manually classifying the cognitive engagement of prior messages. to be able to understand the quality of the cognitive quality of the discussion. And by the way, I want to emphasize something. Cognitive engagement doesn't mean understanding. So what this student is saying could be completely wrong. We don't care about that. We don't care about how much the student understands. We just care about how much the student is engaged with the material and with the others. Because, and that's a very distinct difference between that and some of you might know Bloom's taxonomy, which is another pyramid that educational psychologists like to talk about. That's about understanding. This is not about understanding. It's just about interacting with others. So we did this between study design, where the first half of the last semester course was just as a baseline, so we didn't touch anything. But in the second half, we applied seeding in different treatment groups that I'm going to tell you about. So for about 12 lectures, we did a real randomized control study where we selected candidate seeds from past course instances, and then we ranked seeds according to a scoring function, as the seeding scoring function, or some baseline that I'll tell you about in a minute. And then we presented the top 15 seeds according to the scoring function to the course instructor for review. And so we didn't just automatically publish them. We allowed the course instructor to vet them and to make sure that they're consistent. And I'll say that a little bit about that in a minute. And only then did we publish the seeds. And then we can, of course, see the effects of the seeding on how the students actually react in the course. So yes, the students did participate in a randomized control study in the course. We got their permission to do so. And by the way, some of the students didn't wish to allow us to publish the data, for example. We had to take out their data from the study. And I'll say a few more words about that at the end, about the ethical implications of all of these studies that we're seeing here. So we had two active groups that were seeded. One was called LONG. The long group was a baseline heuristic. It looked at the length of threads in prior instances of the course and selected those that were longest as a baseline. So you're going to receive seeds that generated the longest threads in past instances of the course. And for that cohort, we're going to generate comments. I want to say something. The cohort was a section. So each section has their own copy of Nota Bene on their reading. So if you're in the long cohort, you're not going to see any of the AI generated messages, for example. So the seeding score for the long cohort just depended on how popular the thread was in a past instance of a course. And the seeding cohort in the AI condition, of course, used this classifier that we built that cared about cognitive engagement and emojis to select seeds from past course instances. And of course, we also had a control group that did not have any seeds. And I should also say, when we generated a seed, we said that the comment was generated by a student who doesn't exist called John Lee. And that's why, part of the reason why we showed the comments to teachers. We wanted to make sure that all the comments by John Lee, that seems to be like an early bird student, right? Because the minute that the students are getting the reading, they're going to see the seeds that John Lee, which is of course our active cohort, is going to be generating. And you want to make sure that John Lee doesn't contradict him or herself in the comments that they leave. So that's why we actually involved the course staff to make sure that doesn't happen. And then for each of these groups, we're going to be generating 10 seeds each week. So you
can I ask a question?
Of course.
Sorry, just want to clarify, when you say long group, so is this based on the number of conversations in a thread, or is it based on like text? How long is the text?
No, the number of conversations.
Number of conversations, okay.
Yeah, that's why I mean, by now you might think that it's not going to work, right? By this example, but you see, this is the number of conversations. This is a very popular thread because it had 15 responses. And this is not a very popular thread. It only had a single response. So here are hypotheses. We thought that, we expected that the level of cognitive engagement and the number of responses and also their length, by the way, I'm just not going into it, will be higher for posts in the AI-seeded cohort than in the long-seeded cohort. So that's one hypothesis. The more interesting hypothesis, the one that we really wanted to understand, was if we actually benefit learning. So if you're going to be looking at the final exam grade of those AI-seeded students, are they going to be doing better than students in the control or in the long? And so the first thing that I want to show you is the pyramid. So I'm looking at the quality of discussion. And as you can see here, interactive, I'm reminding you guys, that's the top of the pyramid. This is really beautiful, right? The interactive comments were significantly more likely to appear in when you're getting these seeds that are generated by AI, as opposed to seeds that are generated just by looking at the length of the thread or no seeds at all. And similarly, constructive, which is kind of the lower tier, if you recall, you're going to be seeing less of them when you're generating from AI and more of them when you're generating according to long or control. And again, this was a very it's very hard, of course, to control for everything that might be affecting how students interact in these different groups. You might tell me that it just so happened that the people in the AI group were just better and happen to be better discussants than people in the other groups, and it's hard to say. So what we did do is we compared their grades in the midterm and found no statistically significant difference between the grades and before we started running the seeding. So, that implies that in terms of knowledge, there is not a lot of difference, but of course you can't be sure about that. And I'm the first to say that with these kinds of in the wild studies, you really can't control for everything. This is not a lab study. So let's talk a little bit about the learning benefits. And I should also say this paper is about to be published in Learning Analytics. I just forgot to put the citation. My student Einat master's thesis was running this experiment, and she measured student success in the midterm and the final in these based on relevant questions. So for the purpose of this discussion, a question is relevant if it touches on the material that was in the seeded messages. And so the paper has all of the details, but we were very careful to have seeds in about similar topics in all of the conditions. They were different messages, of course, but they were about similar topics. And that's why, and that was so we will be able to compare students' performance in the midterm and final. And as I said earlier, there was no statistically significant difference in the midterm grades between conditions, but there were statistically significant difference in the final. And in particular, if you do a difference in difference analysis, which is a kind of a nifty linear regression that allows you to reveal a causal relationship, then you could indeed see a causal relationship between being in the AI seeded condition and the performance. So that's really neat, right? Because all you need to do is to select seeds that from the course, so you don't need to work about that. The students have already done the work in the past. You just select the right seeds and you're able to get the students to perform well. And so it's any questions? Okay, great. So it's 6:50. I'll say just one more, go more quickly here because I know that time is clicking, and I also want to talk a little bit about ethics. But the last domain that I'll tell you about is about scaling up collaborative student learning. So what you're seeing here are students working together to solve geometry problems, but there's a single teacher and like 5 or 6 groups of students. So again, what we do there is trying to help the teachers to give them intelligent alerts when they should be intervening. We're not going to be intervening by ourselves. We're going to help the teacher intervene by using AI, because the teacher, her task or his task is to be an air traffic controller. So they are receiving alerts from, again, from this kind of friendly parrot on the shoulders of the student. And as you can see here, we only focused on 3 types of alerts. So are students on task? Are they actually understanding the problem? Are they having technical difficulties? Because we were using this collaborative system that was actually prone to problems, and whether or not they're off task. And it turns out that that's enough to provide a kind of a scaffolding for an alert engine that allows teacher just a little bit of an AI connection, but also just a lot of other things that it's kind of easy to find out, right? Whether a group is idle or whether they're doing a wrong solution. So here we used a little NLP, and this allows the teacher to be an air traffic controller, so the teacher can be sitting down and receiving these intelligent alerts and deciding when to intervene. And I'll just show you so we ran a study. I'm going to end with this video of Israeli television that that accompanied us in the study. And of course, you can't hear me, right? I mean, it's in Hebrew, but it would be nice for you to hear me. And I have no idea. Okay, so hold on. Stop share. I'll just open a different window.
חקרו את טענתו של דני באמצעות Kobi, we can't see the...
I know. Now I'm sharing my desktop.
So when you share your screen, there's like an option that you can click and share the voice as well.
I see. Well, I missed that. But now you can see it, right?
Yeah, I can see it.
Can you hear me? Can you hear?
Yeah.
על כל אחד מכם לרשום את התשובה שלו בחדר הצ'אט. קדימה בהצלחה. תראו מה, זה כיתה של 20 בנים ויש זממת הלכות, אבל כולם לומדים.
בבית הספר אהבת ישראל שבבית שמש אולי לא יצטרכו בקרוב מורות עם עיניים בגב. הבינה המלאכותית עוקבת אחרי העבודה של התלמידים בכיתה, והמורה בודקת את התשובות על המחשב ומתערבת רק במידת הצורך.
אתם רואים שיש לי פה סימן אדום? זה אומר שיש פה תשובה שבויה, אז אני עוברת פה על הצ'אט לראות את התשובות שלהם ואיך הם מדיינים. הם דנים בין עצמם ומפתחים שיח. אני יכולה לתמוך בהם, אני יכולה לכוון אותם, אני יכולה להעיר להם על תשובה לא נכונה. ברגע שיש לי התראה, חבר מהקבוצה לא עובד. אם הוא לא עובד, אז יש לי התראה שאומרת שזה לא בסדר, ואז אני אומרת לו, גלעד, תתעורר, תתחיל לענות.
I'll go back to the presentation. So, she said something very important. She said she decides at the end of the day whether to intervene or not. And during the experiment, what was amazing to me wasn't when she decided to intervene, but when she actually decided not to intervene. So once she said, oh, they're completely off track, they're getting everything wrong, but I love what they're doing. I want them to do some more of that, which shows you what the benefit of the human teacher is and how to help. And so let me summarize and talk about, and of course, desktop, keynote, play. Okay, so lessons learned. I just want to say a few things that I've been learning by working with these socially relevant applications. First of all, you have to connect with stakeholders. We were, like Hadi was asking me, I was working with the instructors in the course in Davis. I was working with the teachers in the last application you saw, and I was working with the Galaxy Zoo admins, because it's very important. You can't expect your algorithm to be developed in a void and then work in the real world. It's not like regular CS papers. You have to dirty your hands and work with the people who are actually going to be using the system. And that teaches you a lot about the actual challenges that you have to face. And the other thing I learned is about how important it is to integrate social and psychology science. So I've shown you many examples when we had to define what motivation was to understand what kind of messages to broadcast, or understand what cognitive engagement was. So I think by looking at the social sciences, this is a real opportunity for computer scientists to make an impact in the real world and to give computational credence to these social and psychological definitions. And lastly, I can't begin to tell you how important it is to be transparent and explainable to the people who are using your software. So it turned out that someone who was who was using the Galaxy Zoo interface got very mad because they didn't realize that there was a machine that's providing him with the recommendations, and that machine was tracking his traffic on the website. Many people are spooked out by something like that, and we're not doing that anymore. Right now, we're working with citizen scientists or with education. We show a little robot that's generating the message or the recommendation to and say generated by by an AI to make it very clear that we are this artificial element. But on the other hand, we also go the extra step to do blogs and podcasts and talk to the community that we're going to enter and explain to them that we're doing things for the good rather than the bad, and everything is anonymous and we don't keep any personal data. And that's very, very important. So, you know, it's increasingly very important for computer scientists to understand about ethical implications about their work. And that's my talk. Thank you very much.
Thank you.
This is my lab, so I just want to say thank you to all of my students. You can see our hike in the Dead Sea region.
Thank you, Kobi, for that wonderful talk and for the wonderful work that you're doing. We do have time for some questions. I have lots of questions, but yeah, I mean, I'm gonna ask if anybody else has any questions.
I'm gonna jump in because I have another meeting and I have to leave. Thank you for that wonderful talk, Kobi. It was very fascinating. I also have like tons of questions, but I want to ask one high level question that I keep thinking during your talk. I love the way that you are kind of combining these ideas of AI with all of these things that we've been hearing from behavioral economics to nudge people into maybe better behavior, which is amazing thing. And on that note, like one of the things that kind of goes back mostly to the Galaxy Zoo project that you were talking about and can apply to the other projects as well, is that over there you're like giving them or trying to decide what is the message that you want to show them. But you're personalizing the message and personalizing the timing of that message. But have you thought about personalizing the questions that they answer? So it could be the case that some of the users kind of get less interested because they're seeing too many easy questions or too many difficult questions. So trying to personalize that based on what they are performing before that, would that help in kind of keeping them more in the system?
Yes, that would help very, very much. So if you could sequence, right? If you could sequence the right galaxy for the right person, not boring them or not frustrating them with galaxies that are too difficult, you'd be doing a wonderful job. That's much. So there are huge technical issues about doing that in particular for that Galaxy Zoo project. But yes, that's something that I'm very interested in. It's task allocation. It's task. AI has been interested in task allocation for a long time. So I think that's a very good area to be doing research in.
And I think there's a particular name for this as well in education technology. It's called the zone of proximal development, which basically corresponds to the zone where the student is not getting bored or they're not being discouraged because they're getting too tough questions one after the other.
Yeah, exactly. And it's kind of like the Turing test. You know, it's good abstract description for what a good thing for how to sequence problems to students, but it's very hard to do because you have right. It's very hard to understand exactly where the student lies and what constitutes as frustration and what doesn't. I can tell you that often I see that when we generate questions that are too frustrating for students, I get very upset about it because I can see the students getting very sad. I mean, we even had the student who cried. We were doing a study in a school in Haifa, and the student got upset. She saw all of these scientists behind her and she started crying. And of course, that's a very bad example of using AI in the real world, right?
Thank you.
Great. Does anybody else have any questions? Anybody?
I have a small question.
Sure.
So for the first example, it kind of remind me of the exploiting problem in computer science. So basically, we sometimes, for example, for some persons they might be more motivated to this question, where some people be motivated by other questions. So does your algorithm also take into account to those kind of mechanism or yeah?
And so the short answer is no, it doesn't. We did some other work where we used bandits to try to generate questions to students. This technique does not, because we don't have the luxury of exploring exploiting. The only thing we did that explore exploits is collecting the training set where we randomly generated interventions.
Okay, so yeah, that's it. Thank you.
Do you have a follow-up question, Angzi?
Yeah, I think I'm fine.
Okay, great. Okay, so I guess I have one more question, unless anybody else has any questions. The question that I have is in the second part of your talk, the classifiers or the models that you built to predict the seeding scores.
Yes.
Can you, I mean, and that this goes into your point that you, or the lessons learned about transparency and explainability. Can you look into those classifiers to see what is it about threads that make them get high seeding scores? And then is it possible to look at what those classifiers are learned, and then maybe we don't need those classifiers anymore? Is it as simple as that we can just learn some rules by looking at what the classifiers are trying to are looking at in determining the seeding scores of threads, and then we can just use those rules moving forward?
We actually used a very simple classifier. It wasn't even a classifier. It was linear. We used linear regression because we wanted to make sure that we could give that we could understand what factors contributed. And a not thesis did do a very nice analysis of the most important features. I mentioned them. So it was the emoticons, whether the first post was a question, those were the highest ranking ones. And of course, the quality of the discussion was very important. And we have an imperfect classifier, but the quality of the discussions. If you look at the paper, you will see a complete list of the features. And I can share the papers, by the way, with everyone. I can email you separately.
Yeah, that'll be wonderful. We have a mailing list, and then I can, if you forward me, I can forward that the papers that you have to everybody else. Great. So I guess we're out of time. I have many more questions, but I know that you have to run as well, Kobi. So once again, I want to thank you for coming here and giving this wonderful talk.